Welcome to the deep dive. Let's get straight to it. How many of you out there making windows, doors, facades sort of wrestle with those headaches? You know, the manual work on long aluminum, PVC, or steel profiles. We're talking late deliveries, that stress, quality that's maybe not quite hitting the mark and just feeling like you're always, fighting to keep up.
Yeah, it's a really familiar challenge, I think. Handling those long, often quite unwieldy materials with the old ways, it just struggles to keep pace, doesn't it, with today's demands for, well, volume and the really exacting standards.
Yeah, exactly. And that's really the focus of our deep dive today, profile machining centers. Now, you might just think, okay, it's a machine, processes profiles, but these are fundamentally different from your standard machining setups.
Right.
Their core strength, it really lies in combining that high precision with automated efficiency. It directly tackles those pain points we just mentioned. I mean, imagine taking those long profiles and doing multiple operations, cutting, milling, drilling, tapping, all in one single kind of streamlined process. That's the power we're exploring today.
Yeah.
It leads to these big leaps in productivity and quality.
And what's really key, I think, is that these aren't just general-purpose machines. They've been specifically engineered, tailored to handle the unique challenges of processing those long, sometimes complex extrusions, and stuff that's basically the backbone of modern buildings.
Tailored for the job.
Exactly, for this specific industry.
So our mission today, it's pretty clear. We're going to dive into the specific advantages of these profile machining centers, really try to understand why they've become, well, pretty essential in this field, wouldn't you say?
Absolutely, increasingly so.
So for anyone maybe considering an investment or just curious about what makes these machines such a game changer, let's unpack this. Let's see why they're so indispensable.
Yeah, and this is where it gets really compelling. When you start looking at the ROI, the return on that investment, it's not just buying a new machine. It's about really reshaping your whole production capability.
Absolutely. And the core advantages, they really spell that out. We're looking at high automation for efficiency, exceptional precision for quality, process consolidation, which saves money and space.
Always good.
High flexibility for different jobs, and even, intelligent features that make them easier to run and maintain. Let's start with that multifunctionality maybe, and how it consolidates processes.
Okay, well, what's crucial here is understanding how these centers pull together tasks that were traditionally, separate steps, done one after the other.
Right.
You mentioned cutting, drilling, milling, tapping, but some can even do things like screwing. It brings it all onto one platform.
It's like taking, several different workstations and just condensing it all
Yeah.
into one super efficient unit.
Pretty much, yeah.
So instead of moving a profile machine to machine, each doing one little thing, it goes through one pass, basically, and comes out with multiple jobs done.
That's the idea. And that
Right.
ties directly into the high automation and efficiency they offer. These aren't standard mills. We're talking sophisticated CNC systems.
Computer controlled, basically.
All right, computer numerical control, running automated cycles, potentially, 2/47 with minimal human oversight needed.
And it's not just the cycles themselves, is it? You've got things like automatic tool changers.
Oh, yeah.
Some can swap out, 16 tools in seconds? And then automated loading, unloading. The whole setup seems geared towards cutting down manual work.
Exactly. Minimizing labor, shortening the overall production time, and really boosting your output. You mentioned potential increases earlier.
Yeah, over 30% in some cases.
Yeah, figures like that are definitely achievable. It's a significant jump.
But, okay, speed's great, but it's kind of pointless without accuracy, right?
Yeah.
Especially with windows and doors.
Absolutely critical. The exceptional precision and quality these centers deliver are paramount. You think about the tight tolerances needed for, say, good sealing, proper assembly.
Yeah.
It's non-negotiable.
And we're talking really precise, like micron level, something like plus or minus 0.01 millimeters.
In some applications, yes. That kind of precision, plus the high repeatability you get from CNC control.
Sure.
Though it's incredibly hard to get that consistently with manual methods.
Right. Too much variation.
And like we said, automation just inherently cuts down the chance of human error. So you get a much more consistent, higher quality end product.
Which, thinking bigger picture, that impacts the final product's performance, its lifespan, keeps customers happy, meets those industry standards.
Precisely. It all connects.
Okay, now for people handling maybe a wider range of jobs or different materials, flexibility must be a big plus.
Huge advantage, yeah.
Yep.
They're built to work with different materials, aluminum, PVC, steel, sometimes even brass. And they can handle complex profile shapes, the intricate designs we see now.
Mm-hmm.
And the beauty is adapting to design changes. Updating the CNC programs is, relatively speaking, quite straightforward. You're not looking at major retooling costs every time a design gets tweaked.
So good for small custom batches and big runs.
Exactly. That adaptability makes them really versatile, suitable for both ends of the spectrum.
And let's not forget the practical stuff. Saving space, cutting costs. Combining machines must free up floor space, right?
Oh, absolutely. That's a really big deal in busy workshops where every square foot counts.
Tell me about it.
But the cost savings, they go beyond just the footprint. You're looking at less material handling back and forth.
Right. Less chance of damage, too.
But a scrap because of the better accuracy, lower labor costs because of the automation, and even optimized energy use, often. Plus, you touched on it, the modular design can simplify maintenance, cut downtime. It all adds up on the bottom line.
Okay, let's pivot a bit. Let's talk about something really crucial, especially for anyone working with those, really long extrusions. The advantage of extended X-axis travel.
Oh.
If you've ever wrestled a 6-meter profile onto a standard machine, well, it's awkward, it's slow, prone to errors.
Definitely.
And if you're making bigger elements, large windows, doors, facade sections, it can just kill your workflow.
And that's precisely the issue the extended X-axis travel solves. When you've got an X-axis that can handle those lengths, typically around, say, 6.5 meters, but some go way beyond that, 74 feet, even more.
Wow.
You can machine that entire profile in a single clamping. That just fundamentally changes the game for long parts.
Right, because extrusions often come in those standard 6-meter lengths, don't they? But designs might need even longer pieces.
Exactly. And these profile centers, they're built with these long travels, maybe from 2.5 meters up to over 22 meters in some extreme cases. So you can handle standard lengths, oversized lengths, without having to chop them up and rejoin them later.
Which introduces its own problems, I imagine. Weak points, alignment issues.
Precisely. So avoiding that is a big win.
And the efficiency of that single setup must save a ton of time.
Oh, huge time savings. Think about it. You eliminate all the labor and the machine downtime involved in unclamping a long, maybe slightly flexible part, moving it carefully, realigning it perfectly, reclamping it over and over.
Yeah, just gone.
Yeah. That's a massive chunk of non-productive time just wiped out.
And some machines, the ones with really long beds, they do something called pendulum processing. How does that boost things even more?
Right, pendulum processing. Picture that long work table. While the machine spindle is busy working on a profile at one end, the operator can be safely loading or unloading another profile at the other end. The work zones are independent.
Ah, okay. So the cutting tool keeps going almost continuously.
Pretty much near continuous operation. It maximizes the spindle's uptime, the actual machining time, and really pushes up the overall output. It's like keeping both ends of the machine busy simultaneously.
That's smart. And linking back to accuracy machining the whole length in one go, that must help precision and cut down waste too.
Definitely. Every time you unclamp and reclamp, you risk introducing tiny misalignments. Right. Machining in one setup ensures all the features, holes, slots, cuts along the entire length are perfectly aligned relative to each other. Plus, less handling means less risk of accidental damage, and better accuracy means less scrap material from setup errors.
Makes sense. And these long work tables, they have special clamping systems too, right? It's not just a flat surface.
Absolutely. They often feature quite specialized clamping systems designed to securely grip various profile shapes all along their length, keeping them stable even during, quite aggressive machining.
Okay, so another big time saver you mentioned, reducing setup time through multi-face machining. I know people listening will relate to the whole flipping, rotating, reclamping dance.
Oh, yeah.
Just to get to different sides or angles. It eats up operator time, machine time, and you always worry about positioning errors creeping in, right? Slows down anything complex.
It does. And this is another core strength of these profile centers. They slash those setup times by using multiple CNC-controlled axes. You've got your standard XYZ for movement.
Right, length, width, depth.
But then you add rotating spindle heads, often called A and C axes or sometimes rotating tables. This lets the machine access and machine multiple faces, often 3, 4, even 5 sides, all while the profile stays clamped in one position.
So it's not just moving along the length. The tool itself can tilt and rotate to get at the sides and ends. Explain those A and C axes a bit more.
Sure. So beyond the linear XYZ, an A-axis typically allows the spindle to tilt, maybe around the X-axis, so it can machine angled surfaces.
Okay.
The C-axis usually rotates the spindle around the vertical Z-axis, letting it approach the part from different orientations. Some machines might use fixtures that rotate the part instead, but the result is the same. The cutting tool can reach the top, the sides, the ends, angled faces, without unclamping. Five-sided machining is actually pretty common now.
That must totally streamline the workflow.
Completely. Instead of stop, unclamp, manually flip or rotate, reclamp. All the milling, drilling, tapping on different sides just happens sequentially in one continuous program, often without the operator needing to touch the part for repositioning.
You mentioned a specific model, Thor Weston PBZ, designed for that one-pass idea.
Yeah, that's a good example of a machine really engineered for that kind of efficiency. Get everything done in a single run if possible.
The time saved by cutting out all those extra setups must be, well, huge.
It really is. You get less machine downtime because it's not stopping and starting for setups, and it frees up a lot of operator labor per part. They could be doing something else.
Yeah.
Plus, and this is crucial again, keeping that single fixed clamping for all the multi-face work. It leads to much higher positional accuracy between features on different faces, compared to trying to line things up perfectly after manually repositioning, which is always tricky.
Right. You eliminate that potential for slight shifts each time you reclamp.
Exactly. The machine knows precisely where everything is relative to that initial clamping.
Okay, so we've hit efficiency, precision, handling long parts, multi-face machining. Let's talk about the sheer versatility now. It sounds like these things can do a lot of different operations, consolidating everything.
That's absolutely right. This is another massive advantage. Instead of needing a separate saw, a milling machine, drill presses, tapping machines, the Profile Machining Center can potentially consolidate all of that, and often more, into one single machine.
So what kind of operations are we talking about specifically?
Well, okay, you've got the basics, cutting or sawing to length. Then a whole range of milling, creating pockets, shaping faces, milling complex contours, slots, and milling for joints, notching. Then all kinds of drilling fastener holes, weep holes for drainage, mounting holes for hardware, and tapping, of course, creating internal threads for screws right after drilling.
And it doesn't stop there, does it?
Not at all. They can often handle reaming for getting really precise hole sizes, countersinking so screw heads sit flush, routing and engraving for more complex shapes like lock recesses, handle cutouts, or even adding part numbers or alignment marks.
Engraving too, okay.
Yeah. Some can do flow drilling. That's a way to form a stronger thread in thinner materials. Scraping or deburring for a cleaner finish. And incredibly, some advanced centers can even automate screw insertion, integrating assembly steps right there.
Wow, okay. Screwing as well.
Yeah. And then you have really specific tasks like lock case milling, opening up handle slots precisely, creating specific circle or oblong holes needed for certain hardware. The list is pretty extensive.
It really sounds like the goal is done in one machining, doesn't it?
That's exactly the goal, to function as a complete processing station for profiles, ready to handle almost every task needed to make those window, door, or facade components.
So maybe walk us through the benefits of consolidating those specific operations, like cutting sawing on the center means
You don't need a separate saw station. Saves space and handling.
Right.
Milling on the same machine lets you do complex shaping right after cutting or drilling. Perfect alignment. Drilling gives you precise holes exactly where needed. Tapping gets them ready for screws immediately.
Right.
Reaming and countersinking ensure accurate fits, flush hardware. Routing and engraving handle those custom hardware preps and ID marks. Marking helps downstream assembly. Flow drilling offers better connections. Even screwing, if available, takes a whole assembly step out. It's all about integration.
So bringing all that together, it massively reduces the number of machines needed.
Significantly.
Yeah.
Which, as we said, saves floor space. But also, it minimizes moving parts around the workshop, less time wasted, less risk of damage during transport.
Yeah, it makes sense.
So it just streamlines the whole production flow, makes scheduling way easier, and ultimately, yeah, it leads to big cost reductions while boosting quality and speed. It hits all the key metrics.
So I guess to sum it all up, it seems pretty clear that profile machining centers aren't just, a nice to have anymore. They feel like an essential tool for any modern window, door, or facade maker.
I'd agree, yeah. Essential is the right word. Their ability to handle long parts accurately, efficiently, do so many operations, machine multiple sides in one setup,
Yeah.
it's really transformative technology for the sector.
And the impact on productivity, on quality, it's undeniable, isn't it? And
Yeah.
in today's market, those are the things that really count for staying competitive.
Absolutely. Those are the bottom line factors that determine success.
Right. So on that note, maybe a final thought for everyone listening to consider. How could Consolidating your current profile processing, all those separate steps, onto one single multifunctional center. How could that fundamentally change your workshop's output? And maybe even more exciting, what about the complexity of the designs you could suddenly tackle?
Hmm. It opens up possibilities.
Definitely something worth exploring further. Thanks for taking this deep dive with us today.